This is question number 16 from chapter kinematics, subsection check your understanding. I'm just reading the question out. Stone projected from edge A of a high cliff strikes the ground at point C, moving almost vertically. The reason for this strange behavior is air resistance that is proportional to the speed of the stone. The points A and B on the trajectory are in the same horizontal level. Time taken by the stone and its upward and downward motions above the level AB differ by delta t, and moduli of vertical components of velocities at point A and B differ by delta Vy. Horizontal component of velocity at point A is ux, and the horizontal displacement of the stone from A to C is r, denoting acceleration due to gravity by g. Find suitable expression for the maximum height of the stone above the horizontal level AB. So this question is going to be tough because air resistance is also included in this, and it's going to involve a lot of integration. And let's see how to tackle this question. Okay. Consider a ABC part, or rather only A to B upward journey. The acceleration is g plus kv. Kv is the effect of air resistance. Air resistance is given as proportional to speed. Since air resistance is proportional to velocity and it is opposite to velocity, it will oppose the velocity as well as every component of velocity. You can verify that. So it will oppose the y component of velocity. Similarly, it will oppose the x component of velocity. So I am assuming this v as y component of velocity at this point. So it's opposing this y component of velocity as kv. And this is the effect of air resistance. And gravity is there. So this is total acceleration. And suppose initial velocity in y direction is u. Now write acceleration like this. These accelerations are with negative signs because we are assuming upward as plus. Separate the variables, integrate, and assume that time from A to B is t, and then simply integrate this to find the time. Okay, consider this acceleration again, but write this acceleration in terms of y like this. Separate the variables, integrate. Now here, what I have done, I have multiplied and divided by k. I have added and subtracted g. This will split the integration into two nice parts, and every term can be integrated very easily because in first term g plus kv itself will get cancelled and will be left with easier integrations. And integrate this to find h in terms of u and k. Okay, so this is the expression we are finding, we are getting for h. And notice one thing, that this log term is exactly the same as we have in the expression for time. So what we can do, we can replace this log term with the time term. And this gives a very nice and simple expression for h versus time. Okay, so this is for upward journey. Now similarly, we have to tackle downward journey from B to C. Again, there are two accelerations. Gravity, it is always downward, and air resistance is now upward because the particle is going down, and it is written as k times mod v because v itself is negative. So air resistance, once it is shown upward, then it should be positive. So therefore I have put a mod there, and the acceleration now can be written as k mod v minus g. K mod v is upward, so it is taken as plus. G is downward, so minus. And if you remove this mod, it will be removed with a minus sign because v itself is negative. Now simple, separate the variables, integrate. One more thing, I've assumed vertical velocity at point C as u dash, and since it will be vertically downward, so minus u dash here, because it's given in the question that vertical velocity at A and C, they differ. So that's why I have assumed it as u dash. And similarly, it's also given that time of ascent is different from time of descent, and therefore I have assumed it as t dash rather than t. Okay, so this is the expression for t dash and u dash. Again, writing acceleration in terms of y now, and integrating this by separating the variables. You can check this. We get the expression for h versus u dash. Now notice that this log term, again exactly the same as we had in the time term, t dash term. So again this log term can be replaced with time term. So finally, we get hk as function of u dash and time t dash. Now what I am doing, I'm writing u dash as u minus delta vy, because it's given in the question that the velocity differ by delta vy, and similarly it's given in the question that time differs by delta t. Now during upward journey, both accelerations are downward, therefore they will reduce this upward velocity very fast. While going downward, net downward acceleration is now smaller because it is effectively g minus k mod v. So a smaller downward acceleration will build this downward velocity slowly. So it will take a longer time from B to C. So therefore, I have assumed it as t plus delta t. Now what I'm doing, I'm just adding 1 and 2, equations 1 and equations 2, and this will get rid of u and gt term, and we'll be left with very nice delta vy and g delta t terms. Just find h from here. So it has almost solved the problem, but there is one more thing. We have to remove this k because k is not given in the question. And for that, to find k, something else is given. It's given that finally the particle is almost moving vertically at d. So almost moving vertically means there is no horizontal component left. So it's given in the question. As we have air resistance in vertical direction, so we have air resistance in horizontal direction as well. So suppose that air resistance is k times Vx. So acceleration can be written like this in terms of x. Separate the variables and integrate. And it's given that initially ux is ux. It's given. Finally ux is 0 because it's moving almost vertically. Initially x is 0 here at a, and finally it's given that a to d, the horizontal displacement is r. So it's given in the questions. So this is how limits are put, and solve this to find k. Now simply put this k back into the expression for h to find h. So this was a nice question, a very nice question, but it involves a lot of integrations. So it's going to be very hard if it ever appears in IIT exams. Okay, I hope you enjoyed this all all maths here. Okay, thank you.